Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, we're going to talk about handling exceptions that occur within your application. We're going to discuss what can go wrong, why things go wrong, and how to build resilient applications that are impervious to crashes through the use of the try-catch block in Visual Basic. So when the compiler catches a data type mismatch in your code, when it catches any unresolved references to classes or any malformed Visual Basic instructions, it'll refuse to compile your application. It'll refuse to compile the Visual Basic code you wrote into a .NET assembly until you fix those exceptions or those problems. These types of problems are called compilation errors. Those are not what we're going to talk about in this lesson. There are other kinds of errors that happen during runtime, or in other words, they happen whenever you have the compiled .NET assembly and it's actually being executed by an end user. So there's countless of reasons why a compiled .NET assembly can encounter an exception, but many times it occurs due to situations that are outside of the control of the developer. For example, if your application can't read or write to disk because the disk is full, or the file or the folder is missing, or it's somehow corrupt, or because network access to that resource is unavailable, or perhaps you're trying to access data in a database and the table that you need no longer works, or the login credentials don't work for whatever reason. All right, these are all reasons why the application might encounter an exception at runtime. And there are cases that the developer could have prevented but didn't foresee. They didn't account for it. A good example of this is doing any validation checking of data that's been typed into the program. This is something the developer should have been able to catch, but maybe they didn't do sufficient testing, they didn't have enough time, they just didn't have the experience or foresight to see what could possibly happen to any input forms on their application. So the user, the developer creates a field that would allow the user to type in the country and expects the user to type in the country correctly, but instead the user maliciously types in numbers instead of alpha characters, and it causes a runtime exception and it crashes the application because that exception was not handled by the developer. Okay, so as a software developer, your job is to make sure that you account for these possibilities. There's also typically in larger organizations a quality assurance team who test your application to make sure that it goes out the door without any defects. Also, sometimes companies run beta programs and have users test the application, but even at that, you can still have subtle bugs creep into an application because the developer, ultimately responsible for the quality of the application, didn't foresee the potential problem. So a friend of mine was fond of saying that 80% of code exists to solve or account for 20% of potential problems that could possibly occur. Generally, software developers should be pessimistic of the reliability of all outside input to the program. So if you rely on a file or a network resource, you should treat it with great suspicion. If you rely on an end user to type data into your application, then you should treat it as being evil, and you should do checks upon checks upon checks to validate that, that text that the user typed in. So this is the software developer's equivalent to driving defensively. You should be coding defensively. And the way, or one way, that a Visual Basic developer codes defensively is through the use of the try-catch block. So what I want to do is open a project that we've already worked on. We're going to work with the read text file while project from back in lesson number 12. And what I want to do is I'm going to perform a little sabotage on this application by renaming the values.txt file to something different. I'm going to rename it to values1.txt. So now when I attempt to run the application, you'll notice that we get this exception. We've seen this before. In this case, it says system.io.file not found, exception occurred and with additional information that it couldn't find the file. It was looking for values.txt in the debug folder, but it wasn't there. All right, so let's continue that, and actually I am going to build this solution. Great. So now let's take a look at what this looks like from an end user's perspective. Let's go to Visual Studio 2013's projects folder. We'll look for the read text file while solution folder, the read text file while projects folder, the bin directory, debug directory. Notice that we now have a file called values1.txt. When I double click the read text file while.exe, this is what the end user would see if we distributed this application to their computer. Now, because this is a console application, they're going to get this full text printout of what the problem is. However, they would typically see, no matter what kind of application it was, like a Windows Form or WPF application, something that looks like this. There was a problem that caused the program to stop working correctly. The dialog says that Windows will close the program and notify you if a solution is available. And so it's kind of an ugly situation, right? You don't want your users, your end users, to experience that. Instead, you want to be able to bounce back from these types of situations from occurring. And so we want to try to account for these, and the way that we can do that is through adding a try-catch around the offending code. And so what we can do is just type in the word try and then hit enter on our keyboards, and this will kind of create the try, catch, and try. So the try is where we're going to put the logic of our code. Anything that we want to ensure that it will work correctly and that we're suspicious of. The stream reader class is something that I'm suspicious of because it works with a string, first of all, string literal values.txt. It doesn't allow the user to pop open a dialog box and select a file. It's hard-coded in a magic string, the name of the file that we want to open. That's the first clue for me. Secondly, it works with a file, and I'm suspicious of anything on the end user's hard drive. They could have tampered with files or deleted files, and I need to account for the possibility that that value.txt file is not on the end user's hard drive. So to do that, what I'm going to do is take all of this code here that I suspect could be a problem. I'm going to cut it and paste it inside of the between the try and the catch. All right. Next up is this catch code block, and I'm going to delete this EX as exception. We'll come back to that. But the catch is the code block that will occur, or that will be fired off whenever an exception happens. And we can do anything we want in here. Typically what you do is one of several things. You notify the end user. Maybe you write some logic to attempt to ascertain what the real problem is, and maybe you try to fix it yourself. That would be the ideal scenario. Depending on what the exception is, maybe you could ask the user, would you like to search on your hard drive for this file? Present them with the dialog, an open file dialog, let them look through, select a file, click open, and then rerun the code in the try. However, in this particular case, we're going to keep it very simple and just write to the console window just a message. Something didn't work quite right. All right. Not a very helpful error message, but it's an improvement over seeing the whole program essentially explode on the user's computer like we saw a moment ago. All right. So we hit the exception. It pops us into the catch where we actually then are printing to screen the error message. Now we can do a little bit better than this, and that's the purpose of this catch EX as exception. Now exception is a data type. It's a high-level class that all specific exceptions inherit from. And we'll see some examples of specific exceptions in just a moment. But all exceptions in the .NET Framework class library derive from this base exception data type. So that means any type of exception that occurs, we'll be able to get a reference to that exception, and then we'll be able to inspect things about the exception. So I should be able to add to this a string replacement code like so, and then use our reference to the exception that was thrown in the try. And there's a lot of different types of information we can get at. The source of the problem, a stack trace, so what methods were called prior to the exception being thrown. a lot of information that might be helpful for developers as they try to look through any telemetry information that lets them know what the user was doing prior to this exception to help them diagnose what the problem is in their own code. But for our purposes, we just want to display what error actually happened, or what the message, a friendly text message of what actually happened. So we're going to use this message property of our exception class. So now when we hit our exception, we get the something didn't work quite right, and then after the colon, we print out the message, could not find the file. And perhaps that's enough to allow the end user to self-diagnose, to look in that bin/debug/values.txt file and realize it doesn't actually exist by that name on their hard drive. But we can even do better than that. In Visual Basic, it's a little more difficult to find all of the potential exceptions that can happen. But as I look at my code, I want to look for those places where an exception could occur. One of the places it can occur is whenever we're actually creating a new instance of the stream reader. Here we're passing it the name of the file, and we know from experience and from this training session and from just reason that this could be a potential problem. Now, where can I go to learn about all the exceptions that could be potentially thrown by the constructor of the StreamReader class? Well, hopefully you're immediately thinking about either a search engine or you're thinking about MSDN. And I was able to navigate to the StreamReader class entry in MSDN. I've given you a shortcut here on screen to get there quickly. But you can do a search on Bing or Google to find this web page. After you've found it, then I'm going to go down to the list of constructors. You're going to see there's a bunch of overloaded versions of the constructor for the stream reader. I know that we're using this second version here that allows you to pass in a string as a specified file name. So when I click on that particular constructor, it gives me the MSDN page specifically created for this version of the stream reader's overloaded constructor. And look at what we have here, a list of all the possible exceptions that could be thrown by the stream reader's constructor that we could potentially handle. And so this is our guide. As we look through these potential exceptions, we should be thinking about handling these exceptions in our code. So a full-blown example would handle all of these. I'm just going to pick two of these, the file not found exception and the directory not found exception. But again, a more full breadth example would account for almost all of these exceptions. Okay, and so what I'm going to do is this. Above this catch-all, catch EX as an exception, I'm going to type the following. Catch EX as directory not found exception, and here I'm going to type in console.writeline the specified directory does not exist, and then I could perhaps give even more explanation on how to go about fixing this problem, but I'm just going to keep this simple. Then I'm going to create a second one, catch EX as file not found exception, and do something console.writeline the specified file does not exist. Check the folder, whatever folder it is, to locate the file. All right, and we're going to leave this final catch EX as exception. So generally, whenever you are adding catch statements to your try-catch blocks, you should start with the most specific exceptions first and then go to the most general exceptions that you would expect to see. So we're starting very specific, directory and file, and then moving to the most general, EX, which, as we said, is the base class for all exceptions. It's the most generalized of all the exceptions that could be thrown. So the next thing that I want to do, we'll go ahead and move this over. The next thing that I want to do is to trigger this first type of exception. I'm going to add a fake subdirectory called boo, and that, by looking in that fake folder that I just made up off the top of my head, we should be firing off this top exception to test our work. And you can see we get the error message, the specified directory does not exist. And so now let me remove that from the constructor and just look for values.txt again. and this time the specified file doesn't exist, check the whatever folder to locate the file. All right, and so if there were other exceptions that were thrown, it would be caught by this catch-all at the very bottom. Okay? Well, there's one last thing that I want to point out about the try-catch block, and it's this finally block that we can add at the very end. And typically what you use this for is to, this is for code that should execute no matter what. And typically you would put here like closing database connections, closing file connections, any type of cleanup work that you would typically do, you would want to put it in this finally statement. Okay. And since we don't really have a complex example, we're not going to use it in this particular case, but you can see that's essentially what the finally statement is for. Code that must be run no matter what, whether this code works successfully or whether it fails. And we fire off one of the catches. Okay. All right, one last thing that I want to talk about before we wrap up here, and that is that as you look at this example, your first reaction might be, well, this is great. I'll just wrap a try-catch around every single line of code that I write, and I'll just add that at the very end of my software development cycle, and I'll be good to go then. And while some developers take this approach, frankly, it's lazy. Those developers are often ostracized by their end users for providing cryptic error messages that nobody can understand, not even the person that originally built them. So the reason that developers do this, however, is because they sometimes take that approach, that lazy approach, leaving exception handling to the very end of the development cycle, of the development process, instead of incorporating it in, identifying those potential errors or areas of the application that could experience problems, things that have dependencies on things that are outside of the developer's control, any connection to anything outside, whether it be the network resources, the file system, any hardware on the computer, you name it. If it's outside of the control of the .NET framework or of the developer, if it's external to the application, then it should be created with great suspicion, and you should attempt to wrap try-catch around it and use the technique we use to find the potential exceptions for that case and handle those. All right? So you should strive to put as much attention into protecting your user from guessing what to do next as possible. If you can fix the problem without the end user knowing it, then you should do it. If you can't, then identify the exact problem and then give the user some options. Ask them what they want to try to do next. So you should protect the end user from losing data at all costs, and you should protect them from feeling stupid at all costs. That's what makes your application polished, and it's what users have come to expect, a reliable experience with no surprises. All right. So to recap, in this lesson we talked about defensive coding through the use of the try-catch block in Visual Basic to plan for the inevitable problems that come as a result of trusting anything that's exterior to your control as a software developer. File system, network access, database, external databases, you name it. We talked about handling special cases first and then handling general cases last, like we did here. We talked about the mindset of the conscientious developer who seeks to advocate and protect the user from losing data and from feeling stupid and from making tough choices or feeling dumb. Using a catch-all strategy is really not ideal, and you should strive to examine each part of your application that relies on exterior resources and then wrap a try-catch block around those parts judiciously. All right, so that wraps up this lesson. We'll see you in the next one. Thank you.